Okay, so now let's move on to partial variation. So the question is, a catering service charges $5 per plate and $30 as a booking fee or a flat fee. So how much do you have to pay if you order 0 to 5 plates, and write an equation for this relationship? So let's have X represent the number of plates that you order and Y represent the total cost. So if you order 0 plates, there's not going to be any charge for the plates, but there's still a charge for the booking fee, which is $30. If you order 1 plate, then it would be $30 plus the cost for 1 plate, which is $5. So 30 plus 5 is 35. If you order 2 plates, then it would be $30 plus $5 plus $5, which is $40. And so on. We already can tell that this is a partial variation because if we were to graph this, the line wouldn't start at the origin. So the equation would be the total cost equals to $5 times each plate plus $30, which is the booking fee. So the formula for a partial variation would be y equals mx plus b. M is still the slope, but b is now the flat fee that you have to pay. But the equation for this problem would be y equals 5x plus 30. So right now we will be talking about direct and partial variation. So let's start with the problem. Bob works at Walmart and earns $11 per hour. His pay varies directly with the time. How much does he earn from 0 to 7 hours? And what is the equation for this relationship? For this, we will need a chart. So let's have X represent the number of hours that he works and Y represent the amount of money that he earns. So obviously for 0 hours, he's going to earn $0. And as we know, for 1 hour, he's going to earn $11. For 2 hours, he would earn 11 times 2, which is 22. And for 3 hours, he would earn 11 times 3, which is 33. And so on. This would be a direct variation because if we were to graph this, our line would start at 0, 0, which is the origin. The equation would be y equals mx, m being the slope. The formula to find the slope is m equals rise over run. So the rise would be 11 and the run would be 1. So 11 divided by 1 is 11. Therefore, the equation would now be y equals 11x. For a direct variation, your equation will always be y equals mx.
Chapter 5.4, Slope as Rate of Change. In Chapter 5.3, you learned what slope was. In this section, you'll learn what slope is as rate of change. So in the example we're going to be talking about, speed is the example of the rate of change. And it's a rate that refers to the change in distance relative to the change in time. So that means you can find out the average speed by dividing his distance by his time. So someone ran 100 meters in 9.77 seconds, and that's distance over time. So we're putting 100 meters over 9.77 seconds, and that's 100, which is the distance, and 9.7 seconds, which is time. And that gives us an approximate answer of 10.2. And you can see I put the approximation dot over the equal sign. So therefore, his average speed is 10.2 meters per second, and his rate of change, which we calculated, is also 10.2, but without the meters/seconds. So here's another example of rate of change or distance over time. The Flash can run 20 kilometers in exactly 10 seconds. So we need to find his average speed or his rate of change. So here we go. His average speed is equal to 20 kilometers over 10 seconds. And that gives us a really nice answer of 2. So therefore, the rate of change, or the flash's average speed, is 2 kilometers per second, and that's pretty fast because he's the flash. And that is an example only of distance over time and rate of change. There are many others, like in the textbook, like blood volume and blood and wing flaps and a lot more, but this is just one example. Chapter 5.5, First Differences. So in Chapter 2, Relations, you will learn how to identify linear and non-linear relations through graphing. In this section, you learn how to use tables of values to identify the type of relation. Our equation is y equals 3x. So I'm writing down the x values 0, 1, 2, and 3. Now our first two y values, which are 0 and 3. Now the third column, which is going to be our first differences column, which we are going to calculate by subtracting our consecutive values of y, which is in this case is 3 minus 0. And the answer is 3. We are going to write down the next y value, which is going to be 6, and apply the same rules as above, and we get the answer 3 again. We'll repeat it at the bottom here with 9, and we get the same answer. Since the first differences are the same, the relation is linear. Our equation is y equals x squared, and I'm writing the first two y values down, which are 0 and 1. Also drawing the first differences column like last time, where the same rules as last time apply. We subtract the consecutive y value, which in this case is 1 minus 0, and we get 1 as the answer. We find the next y value by using the equation, and the answer is 4. We subtract the 2 and we get 3 as the answer in the first differences column. Well, we then find the last y value here, and we get 9 as the answer. After that, in the first differences column, we get 5 as an answer. We then make a second differences column because the first differences relation isn't linear, and we subtract the consecutive values of the first differences here, and we get 2 each time, as you can see here, and that proves that the relation is non-linear because the first differences column is not the same. So here we figure out if the table is linear or non-linear. So let's start with the first one and its first differences. The first differences are 4, 4, and 4. And this is obviously really simple to tell that this is a linear equation because all of the first differences are the same. So therefore, it is a linear relation. The second one's first differences are 3, 4, and 5. And this is obviously easy to tell that this is a non-linear equation because all of the first differences are not the same.